Hello, let me take this opportunity to welcome you to this lesson. I hope all is well there. Today we are discussing quadratic equations. You are most welcome to this lesson. I challenge you to follow it attentively, step by step, and thereafter you do the exercises which are attached in the lesson. To start with, let's see what a quadratic equation is. When we talk about quadratic equation, what is it exactly? When we talk about quadratic equation, it is an equation of the form ax squared. It's an equation of the form ax squared plus bx plus c equals to 0, where a, b, and c are constants. The constants here are a, b, and c. A, b, and c are what? Are constants. And a must not be 0. This is what we call to be a quadratic equation. In other words, it's an equation where the highest power of x is 2. You can talk about an example like if I talk about x squared minus 4 equals to 0, 2x squared plus 5x plus 1 equals to 0. You can talk about x squared minus 2x plus 1 equals to 0. All these are called to be quadratic equations. Why quadratic equation? Because if you looked at the highest power of x in each of them, you realize that the highest power of x is actually 2. So any equation where the highest power of x is 2 is considered to be a quadratic equation. Now, what do we need to know? What do we need to know about quadratic equation? We're going to see how to form a quadratic equation. After knowing how to form a quadratic equation, we shall see how to solve a quadratic equation. To start with, let us see formation of quadratic equation. Formation of quadratic equation. So when talking about formation of quadratic equation, there are a few things which we need to note. One is that if I'm to form any given equation, then I must know what we're calling to be the solutions of that equation. The solutions of the what? Of the equation. I must know the solutions of the equation. After knowing the solution of the equation, I will be in position to form a quadratic equation. Sometimes it is not understood well when I talk about solutions. The word solutions you can also term it as roots of quadratic equation. Now, what does it mean exactly to say that roots of quadratic equation? Like if I have x squared minus 4 equals what? 0 as my equation, and then I'm required to solve for x. If I'm required to solve for x, then that means that I'll be required to find the values of what? I'll be required to find the values of x. So I take this on this side. When I take this on this side, I get x squared to be equals to positive 4. It's a negative. When it crosses this side, it becomes minus. So to get the value of x, I take the square root on both sides, the same as square root of 4. So x equals to positive or negative 2. Square root of a number is positive or negative. Therefore, x is 2 and x is negative 2. Now, 2 becomes now the solution to this equation. X equals to negative 2. Negative 2 also becomes the solution to this equation. Or 2 is the root of this equation. You can also say negative 2 is also a root to this equation. So when I talk about the solution of the given equation, then I'm meaning the roots of the given equation, and I'm also meaning the value of x. When you substitute in this equation, it gives you 0. In other words, the value of x which satisfies this equation is what we call to be the roots of the equation or the solutions to the given equation. Now, for me to form an equation, then I need the roots of that equation. I need the solutions of that equation. Take a case in point. If I want an equation, in that after solving I get x to be equals to 2 and x equals to what? 3. I want an equation that after solving I get x to be equals to 2 and x to be equals to what? X equals to 2 and x equals to 3. Now, if I need an equation, after solving, I get x to be 2 and x to be equals to what? 3. I can solve that. I can look for that equation. How do we look for that equation? We start from here. We need to note that if x equals to 2 is the root of any given equation, then x minus 2 becomes the factor. When you bring this on this side, then x minus 2 is the factor of that equation. And if x equals to 3 is the root of the equation, that means that x minus 3 is also a what? Also a factor. So this is very important. It is something which is very important under quadratic equations, especially when it comes to formation of quadratic equations. Now, let us derive the general term, the general expression to be used here. I will say let alpha and beta be the roots of the equation. If alpha and beta are the roots of the equation, that means that in that equation, if I solve, I'll get x to be equals to what? Alpha, and will also get x to be equals to what? To be equals to beta. Now, if x is alpha and is the root, then that means that x minus alpha is a factor. This is a factor. And x minus beta is also a what? Also a factor. Just by me, I'm bringing this on this side. By me, I'm bringing this on this side. So these are the two factors. If I ask you that what are the factors of 8? If I say factors of 8, you'll tell me 4 and what? And 2. Give me the two factors of 8. You'll say 4 and what? 2. But when you see there's a relationship between 8, 4 and 2, it is very clear that 8 is actually 4 times what? Times 2. So it is not just by coincidence. If I say factors of 9. You will say 3 and what? And another 3. If I say factors of 10, you will say 1, 10, 2, 5, and 10, 1. Now when you see this, you realize that if I get the product of these two factors, I will get exactly 10. I get the product of these two factors, I get exactly 10. I get the product of these two factors, I get exactly 10. So there's a relationship between two factors and the real function. So if x minus alpha and x minus beta are the factors of this equation, then that means that the equation is actually given by the product of the two factors, which is going to be x minus alpha into x minus beta. So this is our equation. The equation is given by the product of the what? Of the factors. Now if I open the bracket, this x times x, that is x squared, x times negative beta, that is negative x beta, alpha times x, negative alpha times x, that is negative x alpha, then plus alpha beta must be equals to 0. So if I pull out x here, x is common, plus the negative, I'll get x squared minus into bracket alpha plus beta close plus alpha beta to be equals to what? 0. Now I want us to look at this equation. I want you to look at this equation. Let us see this equation. Remember we had said the roots are alpha and beta. So if those are the roots, that means that x equals to alpha is a root, x equals to beta is also a root. That means x minus alpha is a factor, x minus beta is also a factor. To get the equation, we multiply two factors. After multiplying, we came up with this, and on simplifying, we have got this. So this one tells us something. X squared minus into bracket alpha plus beta, there is x here, alpha plus beta x plus alpha beta equals to 0, tells us that the equation, if you look at alpha plus beta, these are the sum of the roots. Alpha, beta, these are the product of the what? Of the roots. So we make a conclusion and say that actually, in general, the equation, if the roots are given, the equation is given by x squared minus sum of the roots close times x plus the product of the roots equals what? Equals to 0. So generally, the quadratic equation, if I'm to form any quadratic equation, then it's given by x squared minus sum of x, sum of the roots x plus the product equals to what? Equals to 0. This expression is very important if we are to form quadratic equations whose roots are known. Please feel free to ask any questions. You can tap on our inbox and ask any questions that you feel like. Now let us look at e.g. number 1. Form a quadratic equation in terms of x whose roots are 2 and 3. When you look at this is too simple for us. They are saying that we form the quadratic equation whose roots are 2 and 3 in terms of x. So in part of our solution, we say that if we want a quadratic equation whose roots are given, then that quadratic equation must be of the form x squared minus sum of the roots. Sum of the roots x plus the product of the roots equals what? 0. Now when you look at this, they're saying that the roots of the equation they want are 2 and what? 2 and 3. So what I'll do, I'll first get the sum of the what? Sum of the roots, which is going to be 2 plus 3. The roots are these 2 and 3. So you get sum of the roots, which is going to be 2 plus 3. This gives us what? 5. Then you get the product of the roots, which is going to be 2 times 3, which will give us what? 6. So the equation is going to be x squared minus into bracket sum of the roots x plus product of the roots equals what? 0. So we shall have x squared minus sum, which is 5, but times x plus the product, which is 6, should be equals to 0. So eventually you have x squared minus 5x plus 6 equals to 0. This is the equation whose roots are 2 and what? And 3. Hope that is very clear to us. In case it's not very clear, please feel free to ask any questions which you feel like you need to understand. Now, I want us to go to EG number 2, but before we go there, I wanted to first study this. Form a quadratic equation in terms of x whose roots are 2 and 3. So generally, if you're to form any quadratic equation, then you must know the general expression for a quadratic equation, which is given by x squared minus sum of x plus the product equals what? 0. So if the roots are 2 and 3, then you get the sum of the roots, then you get the product of the roots, then you substitute in the formula. Let's see example number 2. E.g. number 2. Form a quadratic equation whose roots are -3 and 5. So required is for us to form a quadratic equation whose roots are -3 and 5. So I will say my solution. That equation should be in the form of x squared minus sum times x plus the product of the roots must be equal to what? 0. So where are the roots? The roots are here. The roots are negative 3 and 5. Let's get the sum. The sum is going to be negative 3 plus 5, which gives us 2. Let's get the product. The product is going to be negative 3 times 5, which gives us negative 15. So the equation is going to be x squared minus sum of x plus the product to be equals to 0. So we shall have x squared minus our sum is 2, but we are multiplying by x, plus our product negative 15 should be equals to 0. So eventually we shall have x squared minus 2x, then minus 15 to be equals to 0. So this is the equation whose roots are negative 3 and 5. Good. Please make sure you understand this very well. Let's look at e.g. number 3. Form a quadratic equation in terms of x, whose roots are negative a half and a quarter. Form a quadratic equation whose roots are negative a half and a quarter. So in our solution, we say that these are the roots already. The roots are negative a half and a quarter. So if this is the case, then I get the sum of the roots, which is going to be negative a half plus a quarter. When you get negative a half plus a quarter, you will get negative 3 out of 4. Yes, you'll get 1, sorry. It is going to be 1. LCM is 4. By 4, you say here is 2. 2 times this is 2. 2 minus 1, this is 1. Sorry for that. Then you get the product. Product is going to be negative half times 1 over 4. This is going to be negative 1 out of 8. So the equation is going to be x squared minus sum of x, then plus the product equals to 0. We can substitute now. We shall have x squared minus sum. Our sum is negative 1 out of 4. Close times x plus our product, which is negative 1 out of 8. Close should be equals to 0. So eventually you'll have x squared. This will be plus 1 over 4x. This is going to be minus 1 over 8 to be equals to 0. We can as well decide to multiply all through by 8, the LCM. We multiply here by 8, here by 8, here by 8, here by 8. So eventually we shall have 8x squared plus, we multiply here by 8, we shall remain with the 2x minus 1 equals to what? 0. This is the equation whose roots are 1 over 2 negative and 1 over 4. Good. Hope you've been following and hope you're getting it well. Now, to test what you have got, what you've said now, I'll leave an exercise behind here. We can call them exercises or trial questions. You can call them trial questions. Form and equation in terms of x whose roots are part A 2 and negative 2, part B 3 and 5, part C negative a third and negative 1 out of 2, part D negative 2 and 7. So you try these numbers out, try them out, and in case you meet any challenge on the way, please don't hesitate, bring them back and we calculate them together. I thank you so much for being attentive, and I challenge you not to miss the next lesson. Thank you so much. Goodbye for now.